Good morning, friends. I am here again for my course Aircraft Systems. Today I am in lecture number 22, and topic for the today's lecture is pneumatic system and its advantages. I am Dr. Yagya Dutta Dwivedhi, professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. In this module 3, the hydraulic systems I have completed. Now I have the pneumatic systems. In that, we have to cover these topics: advantages, working principle, typical air pressure system, brake system, typical pneumatic power system, component, landing gear system, landing gear and brake management system. These topics I will be covering in 2 to 3 lectures. So these are the topics of the module 3, second part of the module 3. First part is the hydraulic system and the second part is the pneumatic system. In today's class, I am going to discuss about these topics: principles of pneumatic system, advantages of aircraft pneumatic systems, disadvantages of aircraft pneumatic systems, main component of pneumatic systems, and typical pneumatic systems. These are the topics which I am going to discuss today. Hope this will be very useful and very knowledgeable for everyone. So, as of now, I have covered the aircraft systems, module 1, module 2, and half of the module 3. In module 1, I have tried to explain about airframe systems, vehicle systems, avionics systems, and mission system. I have discussed in airframe system about wing configurations, wing structures, parts of the wing, and so on. About fuselage, we have discussed about semi-monocoque, monocoque, longerons, and other parts of the fuselage. Third one is empennage. There we have discussed about the horizontal tail, vertical tail, elevator, rudder, tail cone of the fuselage, and all other accessories related to the airframe systems. Second, we have discussed about vehicle system. If I talk about the vehicle system, in that we have seen the electrical system, we have seen the firefighting system, we have seen the hydraulic system, we have seen the anti-icing system, de-icing system, we have seen the firefighting system, we have seen the air conditioning system, and so on. We have done, and this is the part of the vehicle system. If you and in the third, we have seen that avionics system. Avionics system consists of navigational system, communication system, and computational system. Flight management systems are there. So navigation it can do the communication it can do, and it can make the accurate prediction of future plan of action. Autopilots and other things are working, ILS and all, with the help of avionics systems only. Last but not the least was the mission system. Mission system was used for the military aircraft most of the time. As you know that military aircrafts are used for search and rescue, for combat, for reconnaissance, surveillance, anti-submarine warfare, flood relief, calamities, any other calamities relief. All things are called the mission, and aircraft is deployed for carrying out some specific missions for the particular conditions. In this process, in the second unit, we have discussed the module 2, we have discussed about electrical systems, different AC, DC, their controls, their transmission, 270 volt DC, and so on. We have done it. Then we have also done the air conditioning system, then oxygen system, anti-icing, de-icing system, and so on. We have covered in module 2. In module 3, we have done with the hydraulic systems. In that, different types of hydraulic fluids, their properties, their basic principles, parts, their operations, and other varieties of the items we have already discussed from last 5 to 6 hours. Today I am going to discuss about the first class of pneumatic system. In that I will be covering some basic issues, how it is working and how we can perform in basic pneumatic system. So we have to discuss that, and we have to see, like a hydraulic system, here also principles of pneumatic system. You can see here that the area of the input piston is 2 square inches and the area of the output piston is 20 square inches. If you apply a pressure of 20 pounds to the 2 square inch piston, the pressure created in the liquid will be again to 10 psi. The upward force on the larger piston will be 200 pounds. 10 pounds for each 20 square inches. Thus, you can see that if 2 pistons are used in a hydraulic system, the force acting on each piston will be directly proportional to its area. So, area matters here. If you see here, in this case, we have equal input and output. If you see here that if you can see here that in the first case A, we have area here 10 square inch, here we have 10 square inch, we are putting 100 pounds. So pressure is how much? Pressure is equal to F by A. So 100 by 10, you will get 10 psi. This 10 psi is moving here and area is also same. So 10 into 10 is equal to 100 pounds. So this is same. No advantage. If like this means area is not varying, there will not be any advantage. Next, as you can see in the next case, here area we have the 2 square inch, force is 20 pounds. So how much pressure? 20 by 2, 10 psi. So all this here 10 psi pressure is there, 10 psi. But as and when it is reaching here, the area is 20. So 10 into 20, 200 pounds of load it can lift. So how much advantage? By applying 20 pounds, you can lift 200 pounds by only changing the area. That is the advantage of hydraulic system, and that is the same advantage is happening for the pneumatic system also. So this is the basic principle of any pneumatic system. Advantage of aircraft pneumatic systems. So we have seen that in hydraulic systems, they are the petroleum product, and if you use for a high temperature, there are chances of fire is taking place. But very good advantage in the pneumatic system is it is air. So not flammable. Air is not flammable on its own, creating much less of a chance of fire hazard with an aircraft pneumatic system than there is with liquid hydraulic system. So very less chance of fire in the pneumatic system when comparing with the hydraulic system. It is lightweight. The density of air is very, very less, 1,000 times of less with the fluid or the oil which we are using. It is the density of this thing maybe 880 or 780, something like this. So that much it is less weight. So air is extremely lightweight and does not need a return line like hydraulic fluid systems do. So in hydraulic systems, we need the return line also. So its weight is increased. It is also very simpler. Aircraft pneumatic systems are simpler in design, thus making them easier in design, manufacturing, installing, and upkeeping of your aircraft pneumatic system. Quantity: air is all around us, meaning the pneumatic systems can literally be refilled at any time, anywhere, without even having to worry about the supply. Air is available continuously everywhere, so we should not care of how much we need, how much we have to buy and all. Aircraft pneumatic systems use air which is free. This is brings down the cost. So cost is tremendously reduced. But there are some disadvantages also of the pneumatic systems which we have to take care, and that's why we use the hydraulic system, not everywhere pneumatic system. Relatively low accuracy because it is a compressible. I have told you during my hydraulic systems properties that hydraulic fluid should be incompressible. At high pressure also, compression should not take place. But in a air system, it will compress. So the accuracy will be reduced. Low loading. As the cylinder used in the pneumatic systems are not very large, a pneumatic system cannot drive loads that are too heavy. A too heavy load, it is not able to drive. So a small load only it can be carried. Processing required before used. Compressed air must be processed before use to ensure the absence of water vapor or dust. Otherwise, the moving parts of the pneumatic components may wear out quickly due to friction. So we need air should be purified. So we need some another equipments which to make sure that water and other impurities on the air should not be existing or should not be present in the system. Uneven moving speed. As air can easily be compressed, the moving speed of the pistons are relatively uneven. Pistons are not moving the same speed. It may go less or it may go high. It may vary. Noise is usually produced when the compressed air is released from the pneumatic components. So noise also very heavy comparing to the hydraulic system. So these are the few disadvantages which every pneumatic systems are having, and we should make sure that these disadvantages we should take care of whenever we are using the pneumatic system. So I will just go for the introduction of pneumatic system. Again, air has existing since the beginning of the time. Man has harnessed the power of the wind to power many devices. Only in the last century has man used air as power transmission medium. Use air under pressure is a low power system. Transmitting medium is compressible. Leaks are clean. Components are lighter and less expensive. Air is cheap. So these are the few advantages which we have discussed. What are the applications of this pneumatic systems? It can be used for industrial robots, automation system, operation of the bus doors, operation of the machine tools, operation of the work holding devices, air tools, aircrafts, landing gears, controls, flight controls, doors, and so many other components are also used in aircrafts. Here I have given some general point only. So advantages are explosion proof. It is very fast, easily transportable, easy stored, overload safe, variable speed, variable pressure, clean, simple in construction, stroke setting, no return lines required, wide operating temperatures, and others like compact, light, and it is very easy to repair. Cost is also very less. So basic pneumatic systems, the components which are used for this basic pneumatic systems are air intake, air filter, compressor, after cooler, air separator, pressure switch, safety valve, air receiver, air service unit, directional valves, actuators. I'm going to discuss here about the parts which just now I have discussed here, filter, compressor and all. One by one I will go with some small diagram and I will just give some lights on different components used in the pneumatic systems. So first and very primary component is the filter. So air filter with water separator. Always we use the water separator also, because if the water is entering in the system and if it is in the cool condition, it may freeze, or if the water is there, it will try to make corrosion, rust and other effect will take place on the system. So we should try to filter and also to remove the air as and when it is possible. So here I have depicted a filter which is used for the pneumatic system. So air filter with water separator to filter dirt and the moisture from the airline. So it can filter the dirt. So how it is input, it will come here, it will filter from this side and then it will move here and it will enter in the out, and this is the in. So in this way, and this is the filter element. Here is water is separated. Water, and as and when in between, just we will press it and water will drain out. So this is simple filter which is used in the pneumatic system. Next is the compressor. You might have seen this in the tire shop. They are compressing, in a box is there is a motor and here is a piston cylinder and it is pumping and it is storage here. It takes in atmospheric air, then it is compresses by the piston operated by the motor, compresses the air so as to increase the air pressure, transfers the compressed air into an air receiver. So this is the receiver. This is the motor. Here is the piston and cylinder. It is electrically operated system. Now, air service unit. So what is the air service unit? Air filters with water separator, air filter with water separator, pressure regulator with pressure gauge, oil mist lubricator. So these are the air service units. So in this, first we have the filter. Then we have the pressure regulator. And then oil mist lubricator. So these are the three functions are done by this system. It is a simplified representation here. It is in and here is out. So detailed representation here. It is a filter here. This is a filter. Then this is the pressure regulating valve and this is the lubricator and here is the pressure gauge. So this full system is called the air service unit. Okay, so very important part of any pneumatic system. Next one is the pressure regulator. Pressure regulator is very important because we have to regulate the pressure, otherwise your system may not work properly, and this is also required to have a very safe operation of the pneumatic system. So what are the functions of the pressure regulator? To reduce the air supply pressure. It is reducing the pressure, because if this thing this is creating some 3000 psi, but one system need only 1000 psi. So that is supplied by this pressure regulator. It will regulate how much the system want, that much pressure it will be adjusted. Okay, so to reduce the air supply pressure, to keep the outlet pressure constant even if the outlet air supply pressure fluctuates. Another function of this thing, if the fluctuation of the pressure is there, this valve should make sure that the outlet pressure should be constant. Inlet pressure must be greater than the outlet pressure. If inlet pressure is not more than the outlet pressure, it cannot maintain. Okay, so here we have this valve here. So this you can see there are springs here in and this is out. So it is entering from here. There is a spring damping system. Here the sealing seat and valve disc. Here is loaded with adjusting screw. This we can adjust is how much you want. Here is a plunger. Here is a diaphragm. Here is the valve seat. And it is working in such a way that it is loaded and it will go from here and then it will enter here and then it will go out as per the opening of due to these springs and other mechanism. Here is also one spring, here is diaphragm. This all will maintain a certain amount of pressure and that much only output will go. But the input should be higher than the output. Then if it is 3000 and you want to 2000, 2500, 1000, it is possible. But you cannot get 4000. This is not making that. So it ensures that the pressure is reduced. It ensures that the output remains a constant pressure throughout. These all things are ensured by the pressure regulator. Next is oil mist lubricator. So oil mist lubricator to provide oil mist in the compressed air so as to lubricate the pneumatic components. So there should be some misting of oil so that when this thing is going, the parts are lubricated. Reduce wear of the component, protect from the corrosion. So it is also used to protect the corrosion. So this you can see here that here is the input here and this from here it is oil and it will give the oil mist here. It will spray the oil here and it will go out like this. So it is called the oil mist lubricator. So in this way it is working. Pressure limiting valve. Another very important valve is pressure limiting valve or the safety valve we can say. So it is designed for a certain amount of pressure. If the pressure is more than that, it will exit from the system to prevent the maximum permissible pressure in a system from being exceeded. So if suppose one system is working for the 4000 psi and all of a sudden 5000 psi has come. So there is a valve and this valve will outlet to atmosphere. This is the system pressure and here is these are the springs and they will lift and this will go to this side. It will not go to the output and it will go to the atmosphere. So this is the way, this you can see here. It is shown here. Pressure input. Here is a spring and it will make sure that it will go to the atmosphere. In this way, your pressure limiting valves are working. It is also called the pressure relief valve, adjustable valve. Next, main component of the pneumatic system. This you can see here that here we can start with the reservoir here. Reservoir, then here we have the separator, then we have the cooler, then here we have the motor control center. Here is the intake filter here moving from this direction. Then it is the secondary treatment. Then it is a control valve here and then goes to the actuator, and here we are putting the controls and any operating, and it will move like this or like this as per the direction of the control valve. So, okay, so these are the few very important controls which are used for this system. Here, if you see that it is a general type of pneumatic system. Intake filter is here. The air which is entering from this side is filtered here. This filtered air is entering to the one piston and cylinder machine. Here it is compressed. From here it goes to the cooler where it is cooled down. Then it goes to the separator. From here water is separated. Then it goes to the receiver, and if the pressure is high, the pressure switch will give the relief. And here is the motor control. It is a electrically controlling devices. Secondary air treatment. After this, the air is again treated so that a pure and good air is only entering inside the chamber. From here it goes to the control valve. In control valve, it is trying to control the flow direction. This you can see. In this time it will go from here to here, and it pressurization will be from this side. It will move from this side to this side. But if you want from this side, you change this. This will go here and this will go here. So like this, left or right, your actuators can move as per the control valve directions. Typical pneumatic system. All main pneumatic components can be represented by simple pneumatic symbols. Each symbol shows only the function of the component it represents, but not its structure. Pneumatic symbol can be combined to form pneumatic diagram. A pneumatic diagram describes the relations between each pneumatic component, that is the design of the system. A typical diagram of the pneumatic system is shown in the figure. This you can see here, that power component, control element, processing element, input element, and the supply elements. And here every system has given a symbol. So here these are the actuators. This is also actuators. Here are some valves. Here is the input. Then here we have the motor and other pressure devices. Then goes like this. All the systems are operated. This you can see, the same system is represented in a typical manner. Now air braking system. We have to use the air brakes. If hydraulic systems are not working, we have to use the air brake systems. So air brake systems include aircraft disc brake in the landing gear, used to brake the wheels while touching the ground. These brakes are operated hydraulically or pneumatically. Levers are used in a few aircrafts. Most aircrafts are capable of differential braking. So normally we use the hydraulic brakes, but if the hydraulic brakes are not there or it is not operative, that time we have to use the air brakes. In that, pneumatic brakes are used and it is operated by the pilot, which is flying. Thrust reversals, the engine thrust, if you want to reverse, that time also these things are used. That allows thrust from the engine to be used to slow the aircraft. Air brakes, dedicated flight control surfaces that work by increasing drag. Large drag parachutes are used. Simple brake system I have shown here is with a diagram, and this you can see that brake systems of this aircraft. These are the wheels. This you can see here. And here is the drum. This is the brake drum. These are the brake drum. So how it is working? Just you can see here. Brake pedals. If here pilot is pressing this, one, both at a time, this will be pressurized. Hydraulic fluid will be pressurized. These are called the master cylinder. Here is the reservoir. Brake pedals. Parking brake. If you want to make the parking brake, you just apply from here. This will go directly. And during operation, you have to press both. So this will be pressurized and pressure will go here. Left brake assembly, and this is called the right brake assembly. So how it is working, just you can see here. I am just drawing a brake assembly. There is a fixed rim, and on top of that, this is the movable. So this air pressure is coming in this side, air pressure, and here also air pressure. So what happened? Here is a frictional discs. Lot of frictions are here. Here also friction. So it will come closer and they all will try to hold this due to pressure. So this will be stuck like this. So your wheel will be stopped. So this is the basic principle of any brake system, and in this way the brake systems are working for aircraft, for your vehicle, for your car, for anything, scooter, bike. Everywhere the basic principle is same. If you see in your bike also, you can see one disc. In that disc some shoes are there, brake shoes are there. These brake shoes are the frictional material, and by the pressure of the hydraulic or by the pneumatic, they are pressurized in that. Once we are doing like this, you are getting this all pressure and your wheel is getting braked. Now, what are the failures which are likely to happen in the pneumatic system? So, here we can see that system contamination. If your system is contaminated with some impurities like water, some other chemicals, some other particles, that time also your system may get failed. Solid particles in system can damage pumps and plug valves opening. Liquid from oil, water or other engine cleaning solvent can also damage. Leak within the system also can damage the system. So these are the few causes for the failures which may happen. So we should make sure that the contamination should not enter inside the hydraulic system or the pneumatic system. Solid particles in system can damage pumps and the plug valves opening. Liquids from oil, water or other engines cleaning solvent, leaks within the systems should not happen. Use of pneumatic system. Pneumatic use in small aircrafts. Where we use the pneumatic system, we can use in the gyro compasses. They are a non-magnetic compass in which the true north direction is maintained by a continuously driven gyroscope whose axis is parallel to that of the earth axis. So it is by the gyroscope and whose axis is always axis of the earth. Artificial horizon. It informs the pilot about the orientation of the aircraft with relative to the earth horizon. So it is also a pneumatic equipment also. And turn coordinator. It rolls without the coordinated flight, slip and skid of the left and the right. So these are the few pneumatic systems instrumentation used on the aircraft, and they are working with the help of the pneumatic system of the aircraft. Component of the pneumatic system, we have air pump, we have the vacuum regulator, we have the inlet air filter, we have overboard vent line, gauges, altitude indicator, heading indicators, system indicator. We have the suction gauges, gyro flags, annunciator light, pneumatic air filter. Contamination removes air particles. Clean air is essential for a good operation. Pneumatic pressure regulator prevents system overpressure and ensures proper calibration. So these are the components of the pneumatic system. So this operation of the pneumatic system is shown here. So left pike and the right, red and the green we have seen here. So this you can see here, the LP compressor and HP compressor. Air is taken from the engine, it goes to this, then it goes here to the filter, then it goes to the ground pneumatic supply. If engine is not working on the ground, that time we will give supply from here. Then it goes to the TAT probe, potable water and hydraulic reservoir. Same way, this also goes to hydraulic reservoir, wing anti-icing system, ground pneumatic system, start valve, and air is taken from the HP stage. Then it is goes to this thing, and this air bleed is used, and this is for the Boeing 757 pneumatic system. Here we have the auxiliary power unit. In case of your on the ground, your auxiliary power will supply the pressure to the system and it will work. So in the next class, I am going to discuss about these systems. That is pneumatic system, HP pneumatic system, high pressure pneumatic system, medium pressure pneumatic system, low pressure pneumatic system, pneumatic system components, air compressor, relief valve, control valve, check valve, restrictor, filters, and decant moisture separator. These things I will be discussing in my next class. Hope this will be very useful for you. And these are the references which I have taken from Moyer and the Seabridge book, Aircraft Systems, Mechanical, Electrical and Avionics System. Another book is Moyer and Seabridge, Design and Development of Aircraft System and Introduction, AIAA Education Series. This book, you can use it. Quite good book to understand the aircraft systems. Any questions, you are welcome to ask. I always give my email so that if any questions you can ask from me. So this you can see here that what is the this is my email ydwivedi@gmail.com. Okay, so in this you can ask any questions. You are always welcome to ask questions. Hope you have understood the pneumatic systems basics, how it is working, what are the components, what are the failures and how we can prevent, what are the advantages and disadvantages of the pneumatic systems. And these all will be useful for next class whenever I will be going for further pneumatic system in detailed discussion. This will be useful. Thank you very much for the joining. Hope you have understood, and we will be meeting for our next class very soon. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.